ladies and gentlemen. Welcome to this webinar organized by the World Bioenergy Association on latest technology developments in biomass, pellet and briquette production. My name is Christian Rakosch. I'm president of the World Bioenergy Association, and I would like to welcome you very warmly to this webinar. We have a lineup of excellent speakers in front of us, and as we have noticed, there is a huge interest in this topic. Over 450 people have signed up for this webinar, coming from 81 countries. And the question is, why is there so much interest in pellet production? I think this interest is justified for one reason. Pelletizing, and in some cases also briquette production, is the lowest cost way to upgrade biomass to a fuel that is valuable, that can be used in a variety of ways, that can be transported, that can be used in industrial plants as well as in domestic circumstances for cooking or for heating. So it's a very versatile fuel that you get if you densify, if you dry and densify the biomass and create a homogeneous fuel. That's the purpose of pelletization. That is why this technology has just simply increased in an amazing way over the last 20 years. In the year 2000, global pellet production was about 2 million tons. Today, it is about 60 million tons. And the main production areas are Europe. This is where a lot of the market development started off. Now in North America, starting off in South America, and Asia, China being today most likely the largest pellet producer, even though official data are not available. Estimations go around 20 million tons of pellet production in China, and very, very significant intentions to increase this volume. So it is an exciting technology that we're talking about. It is an exciting topic we're talking about. I'd like to welcome you all very warmly. Before we start with the topical introductions, I would just give the floor very shortly to our media partner. Bioenergy International is a global magazine. It is the official journal of the World Bioenergy Association. Dorothy, the floor is yours.
Thank you very much, Christian. I'm going to just put my short presentation on share here. Do you hear me well? Yes, thank you very much, and good morning, everyone, again. Thank you very much, Christian, for giving us opportunity to say a few words about Bioenergy International. I just want to say that we've been probably the first global focused bioenergy magazine in the world. We've been on the market for over 23 years right now. Just to give you an idea, we started in 2001 and we are doing a lot of stuff. We are making a lot of statistic articles. We are meeting a lot of people. We're going to different conferences, events. And one can say that we are probably the army of people, but we are actually only the 3 people. And it's Alan Gerard, that is editor-in-chief, Janet Fogermark, the front person on the picture that you can see, the brain behind the technique and layout work. And myself, I'm marketing manager and sales manager as well for Bioenergy International, making a lot of networking, meeting customers and getting all the stories up front to Alan, basically. We are basically not just a magazine, we are a media platform. We are trying to be everywhere and cover every kind of, how is it, corner of bioenergy sector. Pellets industry, it's kind of special and very close to our heart. Why we are actually coming from the Swedish background. So today, from 2011, we are also belonging to Swedish Association of Biomass. So we have a lot of background in solid biomass. And right now here, it comes maybe probably the most interesting slide, just to give you a short introduction. We have actually one of our 6 printed edition focused totally on pellets industry. It's called Pellet Special. And that particular edition includes also the big poster that we are producing already from 2004. Where we are trying to put, and we are really precise to make the list of all the producers of pellets, wood pellets in the world on the global scale. The map actually includes mostly producers with at least 10,000 tons per year, capacity per year. However, the one that we started in 2004, it was actually showing all the producers at that time. And just to give you the idea, I mean, when we started in 2004, you had like 195 plants. It was like a global picture at that time. And we can see like how huge the market is and how the industry grow. The data shows to the right, they are actually data from 2022. So we can see that the plants that are having capacity at least 10,000 and more are 1,191. They are from 64 countries. And the estimated production, and again, this is just the production for the plants for over 10,000 tons capacity. There are a lot of small producers that are produce pellets locally for their own use, and those are not included on that particular poster. We are also cooperating pretty closely to Bioenergy Europe. They are supporting us with a lot of information, and we are also getting data concerning N+ certified pellets. And on the last map, we noticed that it was 477 of those plants that are certified pellets. And again, those are also the big one. If someone is interested and really would like to join us as a subscriber and even get the poster, get the magazine, you are very much welcome to get to our website. And just because of this webinar today, you can get also 30% discount, as we are the partner to the webinar, and we are very happy that we can support each other, Christian and Bioenergy Association. So you're very much welcome to join us. And do you have any more questions? Would you like to make some extra promotion? Talk to me about article about your company, your technology. You're very much welcome to contact me directly. Thank you very much. That will be very short from me. Really marketing.
Thank you very much, Dorota. Thank you very much. And before we get right into the topic, just two more remarks. First of all, if you have questions, please post them in the chat. We will look at the chat and we will try to answer the questions related to the individual presenters after each presentation. So please, if you do have questions, post them in the chat. Secondly, all presentations you're going to see today will be available. They will be sent to you as you are registered participants. And the recording of the webinar will also be put on the WBA website. So it will be available in case you have to leave early or anything like that. With that said, let's get into the topic. And as a first speaker, I would like to invite Dr. Martin English. Dr. Martin English is a pellet expert, and he will first give an overview on how to approach the planning of a pellet plant, because that is probably the topic many of you are interested in. How do I get this started? And that's what I asked Martin to cover before we go into the real technology, into the deep technology of pelletizing itself, of briquette production. What is the overall approach? Martin, the floor is yours.
Thank you, Christian. Thank you very much. So Christian actually asked me to give an introduction how to start a pellet plant project. I'll do this on the example of wood pellets, but in principle, the same applies to all other biomasses available. Just a very brief introduction. We are dealing with biomass for, let's say, 30 years. You have seen before on the slide, there is 477 EM+ certified pellet plants. We actually inspect more than 130 of these 470. So in the whole world, so we know quite a lot of these pellet plants. And therefore, we have some experience how you can run a pellet plant, how you can develop a pellet plant, how you can do a business plan. So, and this is what we offer in our engineering consultancy. So we actually offer process developments. You see on the right-hand side, the enriched process for torrefaction, which we developed from the right beginning. We do like very complex plannings. You see the largest pellet silo in Austria, which was an existing one that we did rebuild, and we also developed laboratory equipment. You can see here, this is a pellet tumbler, which is actually sold worldwide. We have sold more than 400 tumblers to pellet plants worldwide. and also in overseas. So from Japan to Chile, you will find our instruments. So enough advertisement. I just start with the topic. There is a couple of pellet plants in the world. I have here an example of a pellet plant that was interesting idea in Austria, starting with a high potential raw material and low competition. You know, they used low quality hardwood, which is hardly used in Austria as a raw material. They started with a very innovative drying and production concept, and reducing their energy, so everything seemed to be really good, and they actually introduced also new machines. But they made mistakes, so they actually skipped the professional engineering. They thought they can do it themselves, and then they had very high downtimes and a wrong product placement in the end, and the plant failed. Another examples, two big ones. The largest plant in Italy doesn't exist for a long time. A huge plant in the US, huge quantity, using economy of scale, good idea. Placed in areas, the one in the area where all the sales are, the other one in a port, easy for export. But the problem was that the raw material sourcing and the logistics was not properly planned, so they failed. So even if you are innovative, you can fail in the pellet business. It needs an approach from the beginning. So from the beginning, from the business idea you have, the first things you have to check is the raw material. Most important for a pellet plant is the raw material. It is the quantity, it is the quality, and is the availability for a long time. Because when you build the pellet plant, it has to run for 10, better 20 years. So for that time, you need raw material available for the 10 or 20 years, and also available during the year. That's the first thing, raw material. The other thing is the product. And there is, when you have a certain raw material, you can just make certain pellets. If you have bad raw material, you cannot make good pellets. So you have the raw material, and you should define the product and the quality requirements you want to get for this product, the market. If you have these two things, that's actually enough. You can already engage a consultant, an engineer, to start with a plant concept, with a business model, and later on with tenderings. I go through all these steps now a little bit more in detail. The raw material, we start with the raw material. There is different options you can use. The classic pellet plant in Europe starts from a sawmill, or from the sawmill byproducts or wastes. It is sawdust, it can be wood chips, it can be offcuts, whatever. And depending on the quality of these residues, you can make A1 pellets or A2 class pellets. What is A1, A2, and B? This is a classification for the quality of wood pellets according to international standards. Well, if you don't have a sawmill and sawmill residues, you can also use logs coming directly from the forest, given they are sustainable and they cannot be used for sawmill or other business. They are good as a fuel. So you can make logs, you can make wood chips, but you can also produce pellets. Pellets have more or less the highest energy density, and is the only form that you can also trade. So when you have a source for a lot of logs, but not a regional pellet market or fuel market, you can produce the pellets. That makes sense. Also, depending on the quality of the logs, you can make all kinds of qualities. You can use wood from agriculture. What's the difference? I mean, this is short rotation plants. They have a little bit of different chemical composition, and you have to check carefully what can be used for the pellet production. And finally, you can use certain fractions of waste, recycled wood, which is clean, like pellets and others. So I have customers and plants which actually work on these kind of residues. It is the most difficult one, and the problem is that you can only make industrial pellets out of these raw materials. So the use, I said, it's important to define the product. Which market do you aim at? Currently, we have two big markets, which are both 50%. One is the industrial market for power generation in Europe. About 50% of the pellets are used in these power plants as substitute for coal, mainly in Northern Europe, like in UK, in Sweden, in other countries. And the rest of the pellets are used for heat and hot water supply in very small systems, in stoves, but also in central heating systems, in commercial units, in a little bit bigger ones, with or without grid. So there is hundreds of different systems used in Europe. Increasing markets are also like alternatives. We see here on the right-hand side, animal bedding, or use them as oil patch adsorbent or as in smoking stoves. These are very small markets, but the interesting thing is that they have, some of these markets have a very high price. For example, smoking stove pellets have about 100 times the price of heating pellets. But of course, it needs completely different raw materials. And an increasing market, what we think will be a future, is also the cook stove market in Africa and Asia, which just started. When you go to the heating market, as shown here, there's much more products you can aim at. As I said, there is small heating systems like stoves, room heating systems, there is central heating systems, there is bigger systems, and there is the power plant market. And all these pellets require different quality. So for example, for the stoves, we look at low fines content in the pellets, we have an even length distribution, and we need little ash content. If we go to the power plants, for example, they are not interested in the length of the pellets. Also, the ash is of little importance compared with coal. Pellets have low ash content, but the chemistry is much more important. So they are looking for heavy metals. They are looking for the ash melting behavior. They are looking for chlorine and nitrogen because that influences their process. So people in different markets look at different quality parameters. So already when you prepare or plan a pellet plant, you have to look which market you want to address. There is also different quality requirements in the standards. I have indicated on the left side A1, A2. For industry, we use the classes I1 to I3 for the qualities. Okay, now you have defined your raw material and you have defined your product. Next thing is, if you want to invest, you need to define a plant capacity. How many tons a year should be produced? As I said before, the product requirements and the raw material available, you have to define the product storage size and the intended trade form. So since I will show later, this is a huge cost factor. And you need a site where to build the plant. And for this site, you need some frame conditions, especially is there infrastructure available. For a pellet plant, you need a lot of power. So if you're somewhere in the forests and there is no power connection, you cannot build the pellet plant. Or you can build a pellet plant, but it may be much more expensive. You also need water, you also need road access, infrastructure, maybe rail, a port, all these things needs to be addressed when you actually define the site. So with this information, you go to the consultant, and the consultant should check the legal requirements because they are different in all the countries, especially like in Central Europe, we have very high regulations or very tough regulations concerning environmental aspects. So the permitting thing is a big issue. The consultant should calculate the mass and energy balance. It should create a basic block chart, meaning putting together the main technologies which are used in a certain plant. And then you have, for all these main technologies, you do evaluation which machine or which system is applicable or good for your specific project. And finally, you create a process flow diagram. I'll go through this. not the legal requirements, that would take much too long, but I'll start with the mass and energy balance. So here is an example prepared for this webinar. We defined a production of nearly 7 tons an hour, 6.7 tons an hour, which produces in 7,200 working hours about 48,000 tons of pellets. This is a typical medium-sized plant in Europe. These 7 tons can be done either by 2 mid-sized pellet mills or one of the very modern big ones. The 7 or nearly 7 tons of pellets you get in the storage, you need, of course, much more raw material. In this case, we actually start with 4 tons of wet wood chips and a little bit more than 8 tons of sawdust with both 50% of moisture content. So the first step, if you see my cursor here, we start with 12.5 tons. We grind them. Well, that's not in the mass and energy balance because that doesn't change the mass. We go to the dryer. In the dryer, we have to evaporate more than 5 tons water per hour. And for this evaporation, in the case of a standard belt dryer, we need about nearly 7 megawatt hot water to have enough energy to feed the dryer. So after the dryer, you go to a dry storage, and then you go to the pellet mill. Usually in Europe, for example, or in Central Europe, you add a small amount of additive, which decreases the energy consumption and improves the pellet quality. And we also need some water for conditioning of the raw material. Then you actually go to the pellet press. In the press, the material is heated up to nearly 100 degrees, and there is again water evaporation in the press and also in the cooler afterwards. Here calculated with about nearly 500 kilograms per hour, and you end up with pellets with a moisture content of 6%, which goes to the pellet store, and then you can go to bulk loading or to the bags. You see in the table, there is the different steps throughout the pellet plant. So now we already know the capacities for the dryer. We know how much raw material we need every hour, and we know how much product we will get. Here is a block diagram, a simple one that shows how the main processes look like. So we start with chips and sawdust. The sawdust doesn't need any grinding, but the chips need grinding. They need a wet grinding, and usually you have a sieve to get rid of contaminants. Then you go to a dryer. In this case, we have here a belt dryer. We need warm water, hot water, to feed this belt dryer with energy. This can be derived from a CHP plant or from another boiler. After the dryer, we can add dry shavings, and we go to a dry storage, which is a buffer between the dryer and the pellet mill. After the dry storage, we grind up the material even a little bit further. This is a dry hammer mill usually used. And after this dry hammer mill conditioning, we go to the pellet press or 2 pellet presses, depending on how many we use. After the pellet presses, we have a product. In most cases, the product goes to a store. There is different options. And from the store to a truck loading station, if you go with bulk, or to a bagging system, a packaging line where you do small bags for end customers. So these are the main processes. And now you have to say, well, okay, main process is one thing, but there is different dryers on the market. Many different concepts. There's different pellet mills on the market. So let's just give some examples what you have to consider next. System decision for the dryer. There is 2 big systems mainly used. There is much more available on technology, but these are the most frequently used ones. A belt dryer, where the material is actually put on a fabric belt in a certain layer, and air is sucked through heat exchangers you see here, and then the hot air is going through the dried through the layer of sawdust that should be dried. It takes up the moisture and it goes up in the exhaust air and is blown to the outside. As said before, you need hot water for that. The alternative is a drum dryer. We see here an example of a very huge drum dryer in one of the largest pellet plants in the world, George Biomass. They have got a directly fired drum dryer, so you have huge biomass combustion systems where they burn the bark, which is not suitable in their case for the pellet production. And with the hot air, to the hot air stream, to the flue gas, the biomass is directly added. You see it here. It passes through the dryer, and the dried sawdust is then separated in these big cyclones and processed further. The wet dryer is more expensive because you need a boiler system in total, but it has advantages. It has a very safe operation, and it has very low emissions to the environment. The drum dryer is definitely cheaper in total investment. The problem is, for example, in Austria, it's not allowed to build drum dryers because the fumes are not clean enough to be emitted to the air, and the filter of the drum dryer costs unbelievable lot of money and is very complicated. So, for example, in Austria, we have to use belt dryers because others are not possible. Example dryer. Other example, the pellet press. We'll hear later on from Andritz. I don't have an Andritz press here. I've other ones, but it's not. This is not important. Important is the system decision. Do you want to use a ring die press or do you want to use a flat die press? There is advantages for both. In principle, in a pellet plant, the press is an important piece of equipment, but it's just one piece, and it's always important to keep in mind that the whole plant has to work. Yeah? And the pellet press is usually not the limiting factor, not the big problem. But you have to make a decision, and you have to also decide, do you use one big press, or do you use more 2, 3 smaller presses for a certain pellet plant? This decision has to be taken into account depending on the availability of raw material, on the safety. If you have just one press and that fails, then the whole plant is not running. All these things have to be taken into consideration. There is so many machines available on the market. And very important is that not all technology offered on the market is suitable for every purpose. It is very, very important, especially for wood, because wood is quite hard to pelletize. It needs strong machines. For agro residues, you have completely different problems in handling and in conveying, which you have to address. But for example, I have put here 2 examples which do not work for wood pellets. Like very small machines, they're simply not strong enough, and the running costs are extremely high, the maintenance is extremely high, and all these systems more or less fail, except you have very specific raw materials like shavings from a small carpenter's shop that works. But if you would like to produce pellets from logs with a small machine, you will fail. It doesn't work. Also, these machines are offered on the market for very little money. We have mobile systems. They are nice, but same system. Very difficult to handle, high costs in operation. It's usually, you have to be very careful. Also, they are very promising because they say, well, just 2 trucks and the system will produce pellets for you, low investment, all fine. But in general, be very careful. Yeah, because it's still a high investment. And if you don't produce the pellet, it will not work. Pellet storage. Again, a system decision. There is 2 big possibilities. One is a flat storage, the other one is a silo storage. And in many plants worldwide, there is no storage at all, so it's directly packed into small bags, and the bags are stored like you see here in this picture. So now you've decided all these things, then you draw a process flow diagram where you actually define the process a little bit better. That is engineering. Just as an investor, just buying without having a flow diagram will have troubles. You'll have a lot of components will fit, will you will miss a lot of components at the end, and finally you do re-engineering and refurbishment from the time you start the pellet plant. So you need a real complete engineering of the plant. Okay, having these done, we make a business plan. So how do you make a business plan? You need expected costs for the raw material. This is what the investor must provide. You need expected price for the product, depending on the market where you want to go, and depending also on the transport costs. You need to know the cost for the power, water, other things, and you need to know your financial conditions, the loan, the capital costs you will get from your local banks. This is what you provide to the consultant, and the consultant should then create a layout, and the consultant should also estimate the investment costs. Invest for the technical equipment, installation and commissioning is one thing, and to invest for the site, the construction and the infrastructure is another thing. Usually you need two consultants, one for the technical equipment and one for the construction. You have to estimate, the consultant has to estimate the operating costs. You can calculate very well in advance. And finally, you make a business plan. So let's go through these steps briefly. I have here an artificial case of one plant we're just building at the moment. You see there is a big wood processing industry already existing. And here in this red circle, we see the pellet plant which we designed together with a partner, Pecon Engineering. This is a big plant with 150,000 tons. We just look a little bit more in the layout. Here you see the raw material reception area with a walking floor, with the material preparation. We have a pellet dryer. We have a dry material storage site. Here is a pellet plant. Here is storage silos. Here is a truck loading station, and here is a bagging station. So this is a full plant like we see very often in Europe. If we want to go a little bit more in details, this is how a 3D planning can look like. Here you see the raw material section a little bit more with redundant wet mills, with a sieve to get out the oversizes. Here is electric chambers, conveyors. Another part is the pelleting section here with 3 big presses, the conditioners, technical equipment. And this is a detail of the truck loading station here in double, because it's a big plant and we have 2 truck loading stations, including suction systems and conveying systems. So this is what you produce, the layout for the customer. Then you actually estimate all the costs. This is an example for this plant. Here is the example for a 50, not for the one you've seen before, but for the one I've shown at the beginning where we did the mass and energy balance. So I calculated the approximate costs here for an Austrian case with about 14 million euros of investment. You see, construction is something, wet material, conveying, drying, dryer, pelleting and the truck loading, the pellet storage and conveying. You need cabling and control systems, installation, commissioning. You need costs for planning and permitting, and of course, always some unexpected costs. So that ends up in 14 million euros for such a plant, which would be a price for this example here. For this example, you can also calculate the operating costs. In this case, we calculate spare parts, which is dies, rollers, which is the belt for the belt dryer and other things. We need consumables, water for conditioning. We need oil for greasing. We need the additive, which is in this case starch. We need the heat for the dryer, which we buy from a CHP plant nearby. We need power. We need, of course, staff, people working in the plant, and we have a rent for the site. So the total operating costs add up to about 3 million here in this case. And having done this, we can actually create a business model. In this case, we have sawdust, wet sawdust and wood chips we use as a source with different prices. We actually sell our product in this case in 60% bulk and 40% in 15 kilogram bags. And we estimate a sales price for 290 euros ex-works for the bulk and 308 for the bag pellets. We estimate 7,200 working hours. And as shown at the beginning, we will end up, when we work for 7,200 hours, with about 48,000 tons. We have some financial partners. We have 20% of equity with 15%. Cost of debt is very low. At the moment, it will increase, which makes it a little bit more difficult. And with these input, we can, and the total investment I've shown you is about 14.3 million euros. We get capital costs of about 38 euros per ton produced. We have raw material costs of about 124 euros, and the operating costs, which actually are made of these parts, consumables, heat, power, staff, rent, and bagging. Bagging is actually calculated for the full amount. So per ton, per pallet, it's definitely much more, of course. So then you have the final production cost, you have a sales price, you have earnings. And in this case, the amortization of the plant would be a little bit more than 4 years, which is a very good time for a pellet plant. Looking here at the production cost in this pie diagram, you can see that the raw material is the main driving factor, and the power and the heat. These are the big things. So what is important is the raw material, heat and power. The investment, the capital cost for this 14 million euros, it's a comparable small fraction of the total cost, production costs. So please keep in mind, when you have a pellet plant, and you save money on the investment, and it doesn't work for the 7,200 hours, you will not be able to produce the 48,000 tons. Maybe you can only produce 20,000 tons because it's not working. Then the whole business plan will not work out, and you will fail, as shown in the example at the beginning. So very important to plan a pellet plant which really runs the planned operating hours. So this was a very brief overview how to produce a pellet plant. With such a business plan, it's a good model. You're ready to order and implement and start the business. Of course, there is much more. Usually it takes about 1 to 2 years to plan such a pellet plant. I've done it now in 20 minutes. So this is just a brief overview. Please keep this in mind. And thank you very much for your interest.
Thank you very much, Martin. That was a wonderful overview and gives our audience a feeling of what we're talking about. If we're talking about a pellet plant in Europe under European circumstances, I will ask also the pellet machinery manufacturers how that is in other contexts, because that may be different. And there are also quite widely differing costs in pellet plants, so how they see that. But before we go to the next presenters, Martin, there are 2 questions from the audience I would like to put to you. The first one was asking whether transport is a limiting factor, the energy demand for transport, how relevant is it, and will it limit the possibility to sell pellets? So maybe you can say a few words about the role of transport for pellets. And then the second question is, what about other raw materials? You were only talking about wood pellets because right now that is the main thing, but it seems like in the future other raw materials will play maybe an even more important role than wood. So what other raw materials have you seen? You have a lab, you're testing pellets. What kind of pellets have you seen in your laboratory? So these are the questions for you, Martin. Please go ahead.
Yes, thank you, Christian. Yeah, we run an accredited laboratory and do a lot of fuel testing for the whole world. And I've seen nearly everything to be pelletized, from all different kinds of wastes to agro residues, coffee, nuts, shells, bagasse, whatever it is. Actually, nearly everything which has a heating value can be pelletized. My colleagues afterwards will probably say a little bit more about that, but it's really everything you can get. Very important is that you just have these raw materials for a fixed price for a long time available. That's important, yeah. And there is a market for nearly everything. There is a market, for example, for sunflower husk pellets in power plant. That works fine. So there is really market for industrial pellets made from agro residues. But again, in this case, it is the heating value per ton you sell to a power plant, which is interesting, and also the chemical parameters. So before you start with any raw material, an investor should check the raw material. If it's not known, you have to do the lab analysis, which is a very, very small investment to be that you get an idea if you can make pellets out of it, or where you can sell the pellets afterwards. And the other question about the transport costs. Transport is a big issue because the raw material has a very low density and transport costs is a big issue. So the pellet plant should be fairly close to the raw material. We actually, you cannot give a precise distance, but I recommend to be less than 100 kilometer, better less than 50 kilometer around the plant. You should get the raw material. And the pellets you can transport, but it's sometimes in Africa, I know there is plants or plans for plants, and there, of course, it's very difficult to transport the pellets to the port, and the port facilities have to be there. That was a limiting factor in Brazil for a long time because the ports were not able to handle the pellets because they need dry handling. So you need certain logistic properties, yeah, and this is something you have to check in for one given project.
Thank you, Martin. Yes, let me just add one thing that at the World Bioenergy Association, we're particularly interested in the use of pellets for domestic cooking, because that is an application that has a number of advantages. It's very clean, it can be used with locally available raw materials. We have a working group, so if you're interested in that, please feel free to contact us to join our working group. We're trying to monitor what is happening in this field, and we see a growing dynamic because there are lots of advantages and a lot of raw materials that are possible to be used in these gasification cook stoves for domestic heating. So there is very little limit to raw materials that can be used, in fact, as Martin has mentioned. With that being said, yes?
Just one last thing. I see a lot of chats coming in the chat, which cannot be answered at the moment. But for example, explosion protection and all these things are very important issues. But this webinar is definitely too short to talk about all these things here. Yeah. But
okay, thank you. Thank you for that, Martin. Yes, so important is proper engineering, not just buying different parts and pieces and believing this is going to be a working plant. So experience is key for a working pellet plant, and please keep that in mind. With that, I'm going to pass the floor now to Olaf Nering. He's Senior Area Manager at Amandus Kahl, a very important producer of pellet machinery. Olaf, the floor is yours.
Thank you. Thank you very much, Mr. Rakosh. And can you see my presentation now on the screen?
Not yet.
One moment. Now you should have it.
Yes, now it's there. Perfect.
Okay. So my topic today, global trend towards high efficiency wood and biomass pelleting plants. You can see Amandus Kahl has a little bit more global approach in this industry. We supply complete plants, and we supply single machines for wood pelleting, for agriculture residue pelleting, and many other raw materials which have an heating value. So, and Amandus Kahl is a made in Germany company. We are from Rheinbeck, close to Hamburg in the north of Germany. We are family-owned business, and the whole Kahl Group has more than 900 employees worldwide. So we are one of these typical German mid-sized technology leading companies in the industry. So, and I thought a little bit what to present today here and what is now important for the audience here, because there's a variety of speakers who address different things here. Amandus Karl today, maybe you don't know this, we are the market leader in the high performance pellet mill larger 500 kW. Basically, we are the market leader above 400 kW, but I want to go now into the 500 region. And we have here this Karl model 65-1500 with 630 kW, 10 to 12 tons capacity, right? And more than 100 machines built already. There's a significant number when you calculate these whole capacities together. Yeah. So, and Mr. English in his presentation said you have to compare ring die or flat die, and what are the advantages. And I think it's really worth to take a look into this. What are the advantages in the technology? And that's what I can only ask anybody who wants to build a pelleting plant for biomass or for wood. Take a close look. What is really required? What are your targets, and what are the important factors in OPEX afterwards? And there is a significant differences, not only in the pellet mill. So first of all, we also do another pellet mill now. We make it a little bit bigger. We go with 800 kW. We go to 13 to 15 ton basic capacity. And this all on the substantial numbers of 400 and 630 kW machine in the market. So, and we will address more and more the big plants, although we have also pellet mills with smaller capacities with 132 kW, with 200, 250 kW. This is all available. And you may see the advantage of the smaller pellet mill when I continue with my presentation here. But now in the big pelleting plants, what are the advantages? There are substantial savings in plant design and operation when you use the larger equipment. You have less conveying elements, you have smaller buildings, you have less maintenance, less operators, and of course lower OPEX in the end, for sure. When one pellet mill does the job of two pellet mills, it has an advantage in the design and in the OPEX. So I hope that this now will run. So for those of you who have not seen a flat die pellet mill in operation, material falls from the top into the press chamber and the rollers rotate on the die plate and press the material through the die plate, and then the pellets are cut off and discharged from the pellet mill. So Mr. English also mentioned different qualities are required in the market. Let's take a little bit a closer look on this. Yeah, the main market today is the industry pellet application. Now, I2, I3 industry pellet are produced, which go into co-firing into the power plants, will be ground and then blown into the power plant and burned together with the coal powder. But a very substantial market is the home heating. So we need durable, high quality pellets, but now without particle size requirements. The industry pellets need a particle size. That's defined in the standard. For home heating, it's not defined. Yeah? And that gives us a lot of opportunities in the plant design. Yeah? So and then we have gasification pellets. This is more a business here in Germany and Japan. These people want to have high quality standards, basically based off EN Plus A1 standard, but also they look into things like clinker generation in the gasifier, which is a substantial point. And then a very strong trend now in Southeast Asia is torrefaction after pelleting. You know, and these people now, they ask for higher bulk densities compared to the normal known standards. They want to go 650, 700 kilogram, because when they do the torrefaction after the pelleting, bulk density is lost. And so they appreciate starting higher with the bulk densities. And this will bring some requirements to the pelleting, extra energy, and that's where we have to find answers to. But let's take a look now, home heating market, or more than 500, 600,000 tons of pellets without I2 standard classification supplied to Japan today, which means they don't need a dry hammer mill. Same as home heating, you don't need a dry hammer mill. In many diagrams, I always see dry hammer mills because everybody thinks you need a dry hammer mill in a wood pelleting plant. No, it's not required. You need it when you want to do I2 pellets or I1 or I3. But for other pellets, it's not a must to have a dry hammer mill. And a dry hammer mill causes dust explosion issues, has high energy consumption to grind something down, and has additional CapEx and OpEx. So, and now take a look, now only in this topic here, on the energy efficiency if you just want pellets without a particle size requirement. Production of pellets without particle size requirements, like EN+, A1 or others. So no particle size requirements. That means we have, for example, a wood chip and we want to do a pellet. And here, with our research, with our work in the recent years, we have developed processes where you can do grinding of the wood chips and pelletizing them with just an energy input of 75 to 80 kilowatt hours per ton. And if you use steam, it will be even lower because you can skip the dry hammer mill here. And that's essential. And that's, I think, to be understood when you want to make your business model for a plant. What is your final market? Is it EN+ pellet? You don't need particle sizes. You don't need a hammer mill. When you use a Carl flat die pellet mill, of course. Energy consumption of a Carl flat die pellet mill, about 50 to 55 kilowatt hours per ton. Yeah, with steam even lower. And now, what about grinding? If we don't have particle size requirements, we don't need a hammer mill and we can take them out, or we just simply don't install them from the beginning. Maybe you leave space for a later installation. That's also okay if you want to have later a market where you have particle size requirements. But a hammer mill consumes 25 to 35 kW per ton of pellets produced. And that's a substantial amount where we have to take a look into it, because we saw the electricity bill in Mr. English's presentation. And we see rising energy costs. So why do we need to grind something which is suitable for pelleting already? And really the answer here is we take the Carl pen grinder mill for the wood chips, grind them down on an energy consumption of about 15 kilowatt hours per ton wet. Well, when I calculate these on the dry pellet based moisture, then it's about 24 to 26 kilowatt hours per ton. And as you can see, the material here in the lower side, on the bottom side, this you can pelletize with a flat die pellet mill. No further grinding with a dry hammer mill required. And you make a very good pellet. You perform all requirements for bulk density, pellet durability. It's all performed very well. So, and this brings really lowest energy consumption from chip to pellet. Only 74 to 81 or 75 to 80 in this range. And this is what we see with many players. This is just the energy consumption of a pellet mill in many cases. And here you have it from including the grinding. So, and that's a very significant point. One has to take a look into it when designing a pelleting plant. And this is research, this is work, this is experience, what we do in Carl and what we can really bring to the industry. And here is an extract of references: Börde Pellets in Germany, Biopelletti Croatia, Einheits Germany, Biopellet Magdeburg. They all use this technology. These people don't have dry hammer mills installed and they make big capacities. And there are many other plants who use this Carl technology to be more energy efficient. So now case study number 2. Okay, I have now an industry standard where I have particle size requirements. Pellets with particle size requirements, 95% smaller, 2 millimeters or something. That is something now what we have to consider and address to. But now, when I put a wood chip into a Carl pen grinder mill, for example, I have already 40% of the material qualified for the I2 pellet standard. So do I need to grind this again in a dry hammer mill? Of course not. I don't need to do that again. So how to do? Screening off the already fine enough material after the dryer and bypass the dry hammer mill. And this saves here 40% on the complete grinding energy. So the energy drops from 25 to 35 and the dry grinding down to 15 to 20. And less machines, less stress, less work, wear parts on the hammer mills. I know hammer mills are always in my markets in Asia. People don't like hammer mills because of dust explosion, filter cleaning, fire risk, so many things why people don't like hammer mills in the plant. So that's where we need to find, as an industry supplier, we need to find answers. And here we have very good answers. And this is a very energy efficient system to make pellets. And you can calculate yourself with the energy costs you have in your country. What does it mean to you? Okay, now coming to one thing. Now you also want to know what's going on with pellet mills. And how to increase operation reliability. And there's also too many things, not really address to people always said, oh, you need this kind of pellet mill and you have this and you need this. But that's not the answer. We need technical points where we make the whole process more efficient in the pelleting process. We saw now grinding, there's a lot of potential in the grinding, but also in the pellet mill, there's a lot. Because the issue in the pellet mill is always gap control. The better you can control the gap, the more efficient your pellet mill runs. And what does it mean? The gap, once set, as soon as you start pelleting, the gap is lost. What that happens, there's wear and tear on the dies and the rollers. So the roller diameter starts to shrink by wear and tear, and the die is reduced in thickness. And then the result is a widening gap. And this causes lower capacity on the pellet mill and higher energy inputs and more wear and tear. And in the end, higher OPEX. How to avoid that? So we want to keep this gap as stable for the longest time possible. That we don't lose the gap already after half day. And then we start having the deteriorating process here that consumption of energy goes higher and capacity goes down, and same as pellet quality comes down and wear cuts increase. So we have introduced recently for the wood pelleting the automatic gap control systems, self-tearing system with automatic zero calibration during operation. You don't need to stop the machine anymore to reset the roller gap. So for the ones who operate pellet mills here in the audience, they know what I tell now. Maybe it's for some people, it's now a very abstract topic, but for the people who run pellet mills, this is a very interesting feature, how to make their systems in the future more reliable, more energy efficient, and running at higher capacities for longer time. Now, this is PLC controlled. We do this kind of gap control for more than 30 years in other industries, but now we also brought it to the wood pellet industry. So, and this increases the uptime of the pellet mills essentially. We have already figures in the North America up to 150 hours, Eastern Europe 500 hours without resetting. And with the gap control system, this can be increased by 2 to 3 times. So, and that makes it very interesting for the people in the industry to select the card equipment, because I think you can see Amando's Card is the only maker of real industrial flat die pellet mills, whereas everybody else make ring dies. And we are here in the industry and we are very successful because our pellet mills have very significant advantages. So I think, and not only now on the pellet mill, and okay, I know it's a little bit card promotion here, I talk a lot about the advantages, but seeing also the advantages in the grinding system where it really makes sense to look into. So Carl, market leader in highest performance pellet mills in the industry. And this technology from Carl offers the highest energy saving potential in wood pelleting, because from wood chip to pellet with one grinding step only. Production of EN plus pellets and post-torrefaction pellets without hammer mill, not only with the Carl pen grinder mill, and automatic control gap control between rollers and die for extended operation time, higher availability, lower energy consumption, lower spare and wear parts consumption. So these are all the things we have to look in. And yeah, that brings me to the end. That was now a very technical topic here on details in the processes, but from Mr. English and his general introduction, where we have learned a lot, I hope that my presentation opened a little bit your eyes to look into real details of this complete process. And it's really worth to do it. And if you have any questions, I would be more than happy to answer them. Thank you very much.
Thank you very much, Olaf. And in this case, we do need to speed up a little bit because we have still 2 more presentations to go. And for that reason, in case you do have questions, Olaf will be available for you. You get all the contact details in the chat, or we will send around all the presentations. Some of you have been asking, will you get the presentations? Yes, you will get the presentations, all of you. And with that, I would like to give the floor to the next speaker, Dominik Kühner. He is Industry Director for Biomass and Waste at Andritz Feed and Biofuels, also a very experienced company in the field of pellet production, active worldwide. Dominik, the floor is yours.
Sorry, yes, good morning, good afternoon, and good evening, depending where you are in the world. I hope you can see my presentation.
Yes, we can. Thank you.
Okay, thank you very much. Then I will start. I would like to introduce, I'm talking about focusing on the engineered solution to minimize carbon footprint. I'm so looking at more the complete plant solution. A lot of things can be done within the equipment, but it's important that we look also on the complete solution. Going forward, there are raw material discussions to be had. There are discussions about flexibility, change in raw material. And from our point of view, a solution for biomass needs to be able to deal with changing raw material already today, but definitely going into the future. But at the beginning, please allow me quickly to introduce Andritz a little bit. Andritz is a large Austrian company with 30,000 people worldwide. So we have a good network throughout the world. We are set up in 4 different divisions, with the biggest being in pulp and paper. So you can see we have a lot of experience in dealing with biomass, dealing with fibers. We at Feed and Biofuel are part of the separation division, and we have a complete set of portfolio. We have a lot of the key machines which are required in biomass pelleting, but we also work in animal feed, aqua feed, and pet. And we are focusing not only on the individual equipment, but we are also focusing on complete plant solution, starting from the raw material intake all the way to the end, to the offload, including our key equipment. We have a global presence, so wherever you are in the world, there is always an Andritz office nearby. We are not only supplying you equipment, but we are focusing on supporting you also on wear and tear parts. Andritz itself is the largest supplier of dies out in the market, and we are supplying dies for our equipment, but also for all other machines, including flat dies. But coming to where we see a little bit the future from biomass to energy. And it's important that you have to understand regulations and where the market is going. As already introduced earlier, the environment is changing. There are some uncertainty, and we see that raw materials are getting questions, but we're also looking at the whole production process, transport, and that is deciding where the market and the opportunities are going. It's important that we are looking at complete solution, and real wood pellets are remaining the dominant raw material. We have to look at situation where the wood as raw materials are changing, the wood mix is changing, where we are getting the wood from might be changing. Maybe we start designing for sawdust, but then as the time goes on, we are going into wood chips, and we need flexibility. And it's important that we are choosing the equipment flexible enough, not just for now, but also to the future. There are various raw materials out there. The focus is on woody biomass at the moment, but we are looking more and more into agri-residues, depending where you are in the world. Also energy crops, plantation crops. Each of them has a different setup, a different request of processing. So if you are planning for the future and you are looking ahead and you have your raw materials secured for the next couple of years, please keep in mind that regulations change, raw material sources change, and it's important that you allow for the necessary flexibility. From us, we are looking at various different plant solutions for processing, from logs to pellets, but also from chips to pellets, sawdust to pellets. We're looking at agri residue and other fibers. And always, even though if we just supply you the key equipment or the stacks, we are looking to make sure we understand your upstream process, so we can select the right equipment and give you the necessary flexibility for the future. But now coming to woody biomass, which is probably a little bit a topic at the moment. And what we are looking at is we focus on safety and serviceability. Operating a wood biomass pelleting plant, certain risk has already been mentioned. And by designing a plant and designing the equipment, it's important that you have safety in mind and you look at the complete process. It's important that you look at reliability, sturdiness of the equipment within the lifetime of the parts, and design your key equipment accordingly. But the CapEx is not only just in the single machine. CapEx and OpEx needs to be looked at as a complete plant, and the individual steps as well as the plant solution needs to be designed accordingly. But at the end of the day, you have to produce the pellet quality which are requested in the market. It can be domestic, it can be industrial, but again, it's necessary to have the flexibility to produce the pellets requested by your customers. So looking at the overall process, normally, if we are able to start with chips or actually with logs, how we chip, how we treat the raw material coming in. We at Andres, the normal process has a chipping and a wet grinding solution. We are proud that we have supplied Georgia Biomass, the largest wood pelleting plant in the world, as a total solution. And we have chosen the right technology for that application. So within Andritz, we have supplied we're working with mini chips, which gives you a better product, more consistent product, which then helps you in the drying process, gives you a more even moisture, and then makes the dry grinding, which from our point of view is required, because the grinding should be done in the grinder and pelleting should be done in the pelleting machine. We have seen that we are able to save about 10 to 20 kilowatts per ton, focusing on how the chips are produced, including the drying step. Going further down the line, the drying and the dry grinding, having the right chips coming in, sort of having a homogeneous moisture, having a homogeneous chip side, then helps you in the downstream processing. It saves you the energy in the dry grinding. It gives you the right pellet quality, the raw material quality to go into your pelleting machine, and your pelleting machine then can focus on densifying the material rather than grinding down the material as well in a machine which is not ideally designed for it. Going further, we have the pelleting technology where depending where you are in the world, sometimes steam is used, sometimes steam is not used. We have seen if the raw material entering the pellet mill is of the right temperature, the pelleting process is working better. It doesn't spend electrical energy to heat up the material. Using steam is preparing the raw material and reduces the overall energy consumption. We also have focus on optimizing our pelleting process, which will give us a total saving about 15 to 20 kilowatts per ton. And about the pelleting process, we will talk a little bit later. So altogether, what we see out there, that if you are looking further than just the individual equipment, if you look at the overall process itself, There are various opportunities which go hand in hand, which can help you to develop a more energy efficient plant. And we saw the electricity cost earlier, which are a big part of the cost of a pelleting plant. But I think it's important that we're not only looking at cost, we are producing a sustainable, renewable fuel. And we also need to keep in mind that producing the pellets, producing the fuel which we want to sell as a sustainable fuel, we also need to look at our CO2 footprint, and we need to make sure that we are optimizing our whole process in terms of efficiency to decrease the electricity consumption per ton, and therefore reducing the overall CO2 emissions related to biomass. We at Andritz, we have demonstrated the capability of designing this plant. Waycross, or the Georgia Biomass, built 11 years ago, is currently outperforming the nameplate by 15%. So that, with an installation which is already running for 10 years, I think speaks for itself. Our equipment is designed for the purpose and gives the necessary reliability to deliver the performance over time. At the end, I would like to take the opportunity to introduce our new generation PM30. It is a mid-range pellet mill in the 5 to 6 ton area, which we believe is the most common size to be used in the market. If you look at the size of the average pellet plant, especially, maybe there are a few large pellet plants being in planning, but a lot of the pellet capacities are not going to be 200,000, 300,000, 400,000 tons a year. So we have focused on our latest development on the mid-range PM30, where we focused on an increased capacity, improved serviceability and safety. So the people working on the machine are in our focus, increased reliability and uptime. We have changed several features of our system to reduce wear and tear and reduce the mechanical stress of a biomass pelleting plant, which together will give us reduced maintenance times and additional reduced operation cost. We are, of course, still focusing on producing high quality pellets, but we have already 4 machines being delivered in the next couple of months, and we see for this new development saving in capex of up to 15% and a saving in opex to 10%. It's a proven machine, it's a proven design, it's already in the market for 45 years. It's now the 6th revision, meeting the new demands of the industry going forward. And with that, I'm completing my presentation, saving a bit of time, trying to catch up as well. So if you have questions, I believe they will be handled afterwards.
Thank you very much, Dominic. That was also very, very interesting to see how you have developed a system of supplying really entire plants. I would like to ask both you and Olaf for a short statement on the following question. There are very significant differences in the price of pelletizing machines or different machineries in the market. Some pieces are offered at way lower costs than you are offering them. How would you explain to a customer who is new, who wants to do, let's say, a medium or even small scale pellet mill in Africa? How would you explain to him why should he use expensive equipment? And be specific, because I mean, just saying it's a better quality is not enough. Please, floor is yours. Maybe all of you start, then Dominic.
No, I think I would give Dominic the first try, because his machine is cheaper than ours.
Okay, Dominic.
Well, I won't comment on that directly. So we have different type different types of pellet mills. We also have a small range pellet mills in the 2 to 3 ton range, which we have focused on low capex. I think you have to understand where you are in the world and what are your goals. If you're driven by starting an industry in your country and in your region, capex is the driver. And we have a pellet mill size and a machine to meet this demand. If you are growing, if your capacity is getting bigger, if your production is getting 24 hours, 7,500 hours a year, you will start to use different equipment, and you need more reliable equipment. What we see in the market, there are differences in the drive systems. You have gearboxes versus belt-driven system. You have different raw materials. You have softwoods, you have hardwoods. Some places want to use steam, some places want to use binders. It's important that you choose and select the right machine for the right location, for the right raw material. Of course, against very low-cost suppliers, it's difficult to compete as a European supplier. But in general, I think I speak to Carl and ourselves. We are supplying reliable equipment, focusing on the customers which can and want to go down that road. Sometimes when capex is the deciding factors, a different set of machinery needs to be selected to start the business off. But I think our proven concept and our reliability also justifies the price.
Thank you. Olaf.
Yeah, I think it was very nice what Mr. Kühne just said here. And look, as I said before, we are made in Germany. You can visit our facilities here in Rheinbeck, close to Hamburg. We manufacture our machines here according to latest European Union standards, also with sometimes even more stricter German requirements. So, and this, of course, puts a certain price tag on our equipment. So, and that naturally brings also, I would really frankly say that our customer bases to people who really look into global, into production of quality pellets, and they usually want to fulfill and perform and afterwards supply contracts, for main markets. So, and because your question was now specifically Africa, we have supplied a lot of equipment to Africa. So, and in Africa, I think there are more things than just a machine reliable. This is, of course, your own reliable, your own trust that you have to bring in. What is your network? How can you do service in these countries? How are you introduced? So there are so many things influencing a pelleting project that are far beyond any machine now first. Because the easiest, I think this is implement your question now, a made in China company come with a very low cost equipment. Okay, price-wise, we cannot compete. And here I have to really say I'm not in competition with Chinese equipment, makes no sense. But if we have the level of trust to the persons there, going into the details of a plant and really say, that's a good piece of technology, and with this equipment you can make money. Then we have an access, and when we can talk about. It's not only that Africa, we can consider that Africa is always buying cheap equipment. No, you will be far with a lot of surprise at what quality equipment you can find there. When the people know what they really want to do here. So, and then there is always a chance for a high quality equipment. But naturally in Africa, the chances are maybe more limited. But when you go in other emerging markets now, we see a very strong trend now here. The whole industry is very successful in markets like Vietnam. We see Southeast Asia coming a lot with pelleting plants. And there you find really people really considering the advantages of the quality equipment, because they want to perform. And that was also in Mr. English presentation so important. When your plant is based on 7,500 working hours and you can only perform 3,000, then your whole calculation doesn't work anymore. So, and here is something, this is something where it's not so much our job now to explain machines. This is more an understanding of the investor. What does he really want? Well, does he want to have the reliable equipment what other people are doing successfully in the world? Then he will be more than happy with Armando's car equipment because we perform to that level. Okay, thank you.
Thank you. That brings me now to our last speaker. Mr. Jesper Madsen is the managing director of Seals Nielsen, a company that has a very long record of producing briquetting machines. Jesper, please explain to us what your technology is about and where the applications of briquetting are. Floor is yours.
Thank you. Yeah, welcome to this webinar from a briquette manufacturing or machine manufacturing, which is a little bit outside the scope of the other guy. We're also a little bit smaller than both Carl and specific Androids, but nevertheless, we've been into the business for many years, and I have a small presentation here. They want to work, yeah. Well, the theme of this was feedstock conversion to pellets and briquettes, and my agenda is to just give you a short presentation of the company, how to convert waste wood to something valuable, where we are putting 2 cases from Denmark we have made this year. And then last is a little bit not a wood project, but we're getting straw into some valuable feedstock to be biogas. Just a short timeline of the company. We are very old. We have been here since 1889, so I think we are, I don't know if we're older than both Androids and Carl, but anyway, we've been more than 140 years and have made briquetting machines at least the last 80 years. Yeah, a lot of things have happened during these many years, but the major thing happened in 2018, where a German company called Ruf, they make hydraulic briquetting press. They bought us, and since then we have been a part of their company, and I started in 2020 almost. We manufacture the major part in-house, meaning all the machine parts, and also a lot of the welded parts is done inside our factory. And we do that because we need to have of course a certain structure of the product, and also a certain level of quality which we can control in-house, and that's something we've done now since day one. And of course, we could also have a quick delivery when we produce everything in-house. Very important. We also have an R&D department that make specialized projects, and I think 95% of what we do is going to be customized units. We don't sell a lot off the shelf. The major part is done together with the customer. As said, we don't do pellets, but do this kind of briquette. You can see it's a lot of different shapes, sizes, colors, and coming from all kinds of material. What process or what material do we process? Of course, wood, softwood and hardwood, agriculture, straw, rice husk, coffee husk, bagasse, and other stuff like paper, MDF, foam, RDF, and a lot of other things which I will not bring here. We have 3 different kind of processing. We at CF Nielsen do this mechanical press from 40 millimeter up to 120 millimeter, 200 to 3.5 ton per hour, and need, as the other guys, a certain humidity maximum in the product, max 16 for industrial and 12 for consumer. Our mother company in Germany, they make this hydraulic press. I think you are familiar with this square briquette. They have from smaller volumes from 30 to 150, 1.5 ton per hour, and have the same requirement about moisture content as we do. And then the last product is also something we have made now for the last 5 years. We call it Shimada press and extrusion press that actually can make very high density briquettes up to 1.4. And these are made mainly for instance, the pizza market. The mechanical press we produce in Denmark is in these sizes, again, from about 200 kilo per hour up to 3.5 ton, depending on raw material, density up to 1.2 ton per cubic, and have it's like an essential press just laying down. I go only into the industrial part of this of our sales. We have been making consumer products more or less since day one, and now we are facing that the industrial side is going to be bigger and bigger. This is a typical industrial site where we get the raw material into our silo, have two presses that actually do feed up to 4 containers into a cooling line. This can make, as said earlier, up to 120 millimeter in diameter and density from 0.1 to 1.2. Shortened briquettes is important for a lot of customers to make them fit into the boiler system. Simpler way of doing it is to simply by weight. When you enter the cooler line or go out of the cooling line, it break off. Mechanical breaker could also be installed so you can cut them into short lengths. You could also use a puck maker that could make these pucks up to from 10 to 50 millimeter, or a divider system that could go a little bit higher up to 75 millimeter. The briquette could be handled in different ways, as said earlier, into a container or 2 containers. Could be simply placed on a storage place or into a big bag system, which we also produce. I just show you 2 samples from Denmark, which we have had during the last 1 year. And maybe you know this product is a very famous manufacturer of these chairs in Denmark called Kai Hansen and Son, and the chair is called the Y chair because of the shape of this back here. It's a very, very popular one and a very expensive one. And we made a large project with them this spring, and I have a video that's, I hope will work. Christian, it's working, right? Can you hear it?
Vi havde et ønske om i et samarbejde med Carl Hansen og Søn at udnytte alt deres træaffald her lokalt, så det ikke transporteres bort. Og så viste det sig, at der er altså et meget højt støvindhold. Og når man har stor mængde støv, så giver det eksplosionsfare, og det er også vanskeligt at håndtere, både i lagerområdet og inde i kæden. Og i den forbindelse så gik andre vejen, og derfor valgte man at projektere, og det med at få en fast brændsel. Og i den forbindelse har valgt på det tilskud i forhold til de briquettepresser her. Og det kører selv, det starter op om morgenen, og så er det jo en time, der er lidt rengøring, og ellers er der ikke nogen, der gør det. Ved at trykke det til briketter, så får vi pludselig øget densiteten med faktor 4. Det vil sige, at vi har 4 gange så meget energi på lager. Vi har ikke længere problemer med støv. Det er lagerfast, så det kan ligge fra forår og sommer hen til vinter. Og vi sparer de her 350 lastvognstog ind og ud af gennemsnit. Samlet set giver det en CO2-reduktion på 40% for gennemsnit. Og så har jeg det et brændstof så godt, at det ikke købes ude i markedet.
Yeah, a short comment to that is that this company produces these chairs the year round. And of course, in the summertime, there's not a lot of need for heating because this shavings and sawdust and what they have is being used to feed a boiler for themselves and also to the local community for district heating. So they had a lot of trucks going out during from April to November with shavings, which they sold to almost nothing. But what they do now during this period from April to November, they actually do briquettes. And they store the briquette, which could be used in the winter time, and then they can supply themselves and also a larger amount of houses in the local city, which especially right now with the prices of gas that went up last year, has been very popular. So this was good case, and I have another one from a company called the Lillehed, and also a Danish one. I think you might have seen this big beam, glue-line beam for larger houses construction. This is from I think a sports hall, and this is from an airport in Denmark. Yeah, I'll just read the video on.
It's a glulam beams production facility in Hertzhaus that provides glulam beams for the construction industry in Northern Europe. There was just one problem. The supply of heat was out of sync with the demand. The company had way too much wooden fuel in the summer and too little in the winter. And as the loose wood residues were difficult to store for later use, They had to sell their excess residues in the summer and buy supplementary forest wood chips in the winter. The company had to find a better solution. The answer was a large on-premise press from C.F. Nielsen that turns wood residues into storable briquettes. The press has a capacity of 1.2 tonne per hour. The raw materials used for the briquettes are wood shavings and offcuts from the glulam bean production. When the compressed briquettes leave the press, they're hot and need to be cooled down, which is done in the cooling lines. At Lilleheden, the briquettes are transported outside through 20 meters of covered cooling lines into a storage building. Inside the storage building, the briquettes are split in 3 directions to make sure they're distributed evenly on the floor. This is where the briquettes are stored for later use. Once the briquettes are needed for heating, the briquettes are transported to the industrial boiler for burning. Not only has the press helped Lilleheden reduce their transportation and disposal costs, they no longer have to spend time and resources on selling residues in the summertime and buying forest wood chips in the wintertime. And last but not least, the company has had many requests from other heating district plants that are interested in buying their briquettes.
Yeah, that was another case story from Denmark, and that's quite unusual. We have never made these type in Denmark earlier, but within this last year, because of the crisis in Ukraine and the gas prices and the energy price gone up, these products certainly got a boost, and actually now it's on the move. And we can see that generally that a lot of companies that have this kind of waste, which they earlier considered to be a waste, now looking into doing it a little bit different, not only for getting more fuel for heating, but also to reduce the amount of CO2 for transportation. In this case, both of these companies are using a lot of trucks to take away this shavings and dust during half a year. Now they can keep it all in-house and use it to benefit a lot of people in the surrounding. So that was a couple of cases from the briquetting side, and just to go through the focus areas where we're into now is, of course, agri waste. A lot of waste everywhere from the agricultural industry, and a lot of it's just been burned in the field. We have torrefied wood, which is a new kind of a new segment we're going into. We have just get an order for a large torrefied wood installation in Finland, which is going to be made within the next 1 year. Quite exciting. Charcoal for consumer, which is also a kind of a leg we're working on, and industrial biocoal. This whole industry about trying to get something that could replace coal as a firing for power plants, for cement industries are really something we can feel now is a booming. So we are into a lot of projects where it is going to be, and the output going to be one of these 4 type of waste material handling, which I just showed you. I told you other business is to use briquette straw to speed up biogas. We have a different company called Kinetic Biofuel that can offer a complete concept for handling of straw from bales to briquettes, and then be put into the biogas production as a feedstock. Kinetic Biofuel is a partnership of 2 companies, C.F. Nielsen, where I come from, and the Biofuel Fuel Technology, and we have the patent. The patent is consisting of the principle of using straw through a briquette press and then using this briquettes into a biogas plant. That's our patent, and no one else in the world are kind of allowed to do that. The reason why it's so good, we'll call to a good thing to put it through the briquette press, is that a straw normally looks like on the left side, looks a little bit like this. It's totally closed and actually don't take water in. It's floating on water if you put it onto water. If you briquette it, you totally destroy the structure of the straw. And this is a briquetted straw, and then you put water to it, it kind of develop quickly and absorb the water very, very quickly. And that's quite a difference from if you use normal straw into a biogas plant. And that's a patent we have that actually uses this type of or principle by a steam explosion of the straw. The press design for this is the biggest one we have is the 75 pen that have a capacity up to.
You're muted. You're muted. You're still muted. Yes, but we cannot hear you. Okay, let's try with the headset. Still muted.
Okay, what now?
Now we hear you.
Okay, I try to go into the presentation one more time.
Fine.
And go to where we ended, which was, I think, around here. Okay. We'll try again. Just a brief principle description of how the press is working. It is an eccentric press. You have the big flywheel. You have an eccentric attached to the shaft, and then you have a piston moving back and forwards here, and actually press the raw material, which could be straw, but also kind of wood, in front of the piston, and press it through this die where you have a reduction of the diameter. And this, in fact, is the only place where you add energy, and you don't add anything else. You don't put any binders in, but simply by this kinetic energy, by pressing material through this die will make it bind, also straw. Then why should you use it to this biogas plant? Why use briquette straw and not just normal straw or other kind of feedstock? Just to show you how it absorbs water, it's just very simple. Test here where you put 100 grams of briquette straw and normal straw into 2 small glasses here. This is from start, and after 15 minutes you see what happened. The briquette straw absorb water very quickly, where the what you call the normal straw, which just been shredded, still don't really absorb water. And that's the whole idea of using it. The number or the amount of water to be absorbed by briquette straw is 7 to 10 times higher than from shredded straw. Another issue in a lot of countries in Europe, or especially German, is that you're not allowed to use corn chilies, for instance, as feedstock, because it's considered to be the first generation raw material, where briquettes or wheat or straw from wheat or barley or corn is going to be what they call a second generation raw material, meaning a waste. So we intend to use this waste and make it into something valuable. By putting stored briquettes into the biogas production, you can have a yield of approximately 300 liter methane, corresponding to 250 liter methane per ton straw. You could also, of course, have a lot more briquette on a truck when you briquette it, instead of having bales on the truck, which is logistical and CO2 footprint also an big advantage. Straw briquettes are dense, and the handling of in the biogas plant is quite simple. So if you feed a biogas plant with briquettes, it is much easier to run it, because it's very consistent, the material you feed in. And as I said, this concept is patented and proven through tests at the University of Aarhus in Denmark for many years. And again, there's a lot of straw available everywhere. And a lot of this is just considered to be waste. We've been testing this for 5 to 6 years at the university in Poland, where we have made a lot of tests and have documented all these results of exceeding the biogas yield per ton straw. So if you're interested, I can send you a lot of these test reports. And we also have briquette presses or total plants running. This is how a typical setup we're going to be. You have the bale coming in, going to a sweater, stone trap, hammer mill, cyclone filter, big mixer or buffer silo, through a screw conveyor with sand removal into it, dosing silo, and then to the press, and you have briquette coming out here. We are taking 2 customer cases with me. One is from UK, which from farm renewable biogas. This is a plant in built up, and you see in the back you have the big stack of bales from most likely wheat or barley. The whole plant is set up like you have the conveyor or the line for the bales. You have the hammer mill and the cyclone. You have the mixer. You have our silo, and then you get the briquette out. And these briquettes are being mixed in a mixer together with some other raw material they have. It could be slaughtery waste. It could be from other kind of industry where they have some agriculture waste they want to use, and then into the biogas plant. And then they have this rather high amount of gas related to when you use normal wheat straw or barley straw. Another big one is coming up in Denmark now. It's a really huge project in Vordingborg, which is in the south of Denmark, where they need 500,000 tons of briquette straw to be put into this plant. It most likely been put in place or the investing is being done within 1 month from now. The feedstock is biomass. It's going to be briquette straw and some renewable energy from windmills, wastewater, and the output going to be biomethane, about 150 million normal cubic meter per year. CO2 is going to be a product coming together with the methane, which is basically free. So what the intention is to build a factory next to this one, where they can take this CO2 and use it together with electricity again and water, and then make jet fuel or other fuel for whatever industry needed, and then some fertilizer. So especially this area is something that's really booming now in Denmark, and the reason to why we of course are interested in this is that we want to supply a lot of these satellite briquette production sites, roughly about 60,000 tons of briquettes per year, consisting of 4 presses and the whole preparation line and the stock here. And I think Christian mentioned that earlier, that of course, or Martin did, that it's essential that these production sites are close to where the straw is. So there's going to be several places in Denmark where you have a lot of straw available to be able to process and put into this production site, and then it's going to be taken from here to this big plant you saw earlier. So this industry is really something we look forward to, but it also give us some I'd say capacity problem. These are going to be put in life, and that looks to it now anyway for within a month. So it was a short, a little bit different introduction to use of waste wood and also waste biomass from a company that makes the briquettes, not the pellets.
Thank you very much, Jesper. And to close this webinar, just one more question to you, Jesper. One of the participants has asked, so what is the market trend for briquettes? We see very strongly increasing trend for the pelleting. Do you see a similar trend for briquetting? And what is your view on briquettes outside of Europe? You have placed a lot of emphasis on European applications. How do you see the briquetting world beyond Europe?
If you take the first question about the future for briquetting, we said earlier, we have the major part of our customers are consumer customers or have been consumer customers, meaning that you make briquette to put into a 10-kilo bags, and then you can buy it in a local Bauhaus or whatever place they have been sold. And this also booming because of a lot of people are trying to convert from what they had, the gas firing last year, into some heating source that it's easier to handle and cheaper. So that still is that thing is still booming, maybe not so hot as last year. We are not only selling in Europe. Just to take the last 4 months, we have been making installations of this kind of briquette press in Canada, in US, in Chile, in India, in Kenya, in New Zealand, in Australia. So it is a worldwide product, and half of these installations are for industrial purpose, meaning they have some waste from a sawmill or from also we are now going to install a big site in Kenya for the bagasse, making briquettes out of bagasse for sugar canes. So it is for us also not only for the pellet manufacturer, but also for us a very busy time, and not only in one segment, but in a lot of segments. And this straw business I showed you here last could really add a lot to our turnover within the next couple of years.
And one final question, is the investment cost for a briquetting plant of 50,000 tons comparable to what Martin showed, or would it be less, or would it be more?
Cheaper. No, well, as you can see on maybe on this, and we normally in this case also for straw we take or want to have dried material into our process. We don't sell dryers. We don't sell, preparation line from a hammer mill or dryers or working floors. So of course, the part of an investment when you talk about this system you can see on the screen here, this is rather cheaper than if you need to have the whole line. So I would say per this 60,000 tons of equipment, if you take this, you see on the screen here, we talk maybe about 3 million euro for 4 presses and a preparation line. But then we still need to have, of course, straw is normally dry. If you take the bales, they are normally between 15 and 16% of moisture, and that makes life a little bit easier than if we need to dry the material before that.
Sure, but I think that is a very interesting aspect, that there is way lower investment cost for briquetting than for pellets, and that has obviously advantages for places where people would like to invest less.
And just to finalize the question about prices and competitive prices when you go to Africa, you're right, and also Olaf and Dominic is right that we are also more expensive. If you take our prices and compare that to prices you can buy from India or from China, we are way above. But also considering the number of hours that what the customer like to run, maybe 7,000 hours a year per press, they cannot run that in general Indian press or Chinese press. Not to say something bad about these, but the level of quality and the level of the component used are different. And of course, the prices are different. So depending on what the need from the customer, what it is, and what how many hours they want to run per year, how much maintenance they want to have, how many people they want to look at it. So it's not black and white.
Okay, thank you very much. Ladies and gentlemen, we are at the end of our webinar. Thank you very much for participating. Please make sure that you watch our upcoming events. We have a series of ongoing webinars, and please also have a look at our website, worldbioenergy.org. This is where you can see also an inventory of webinars we did in the past that are all very interesting. Thank you for joining us and hope to see you again. Goodbye.
Bye.